Hello, welcome to another IoT Central session. Please send any question that you might have directly in the chat, and we will make sure to follow up with any unanswered question with the email you provided when you registered. EdgeImpulse is the world's leading embedded machine learning platform. It helps you build end-to-end machine learning pipelines to accomplish a wide variety of machine learning tasks, such as regression, image classification, sound classification, object detection, and also predictive maintenance. You can import any data from any sensors and deploy to almost any devices. And what is important is that you maintain control over your data and your firmware the whole time. EdgeImpulse Studio is an online platform that is designed for developers, for embedded developers, and it handles everything, including the data collection, designing your impulse, meaning adding a mix of pre-processing and learning blocks, testing your models, the accuracy and how it will behave in real conditions, and then deploy it to almost any devices. And we also provide ready to go firmware in case you want to test, or C++ library, other kind of components that you can include in your projects. This being said, my name is Louis Moreau, and I'm a developer relation engineer with EdgeImpulse. In this session, I will speak about the EON Tuner, which is our AutoML tool, but not only, it also includes Auto DSP. And the goal of this tool is to help you achieve the best model accuracy while respecting your device constraints. So when it comes to embedded machine learning, we should focus also on the device. So the device has constraints, and we also need to find the right balance between the signal processing and the ML, so the machine learning block, to make the most valuable of it. So it can actually be quite complex and can contain several parameters, whether it's your input data, so the buffer size that you're going to classify or to infer. Then you have the pre-processing. You can use several techniques such as fast Fourier transforms to pre-process the raw data and then pass that along to the neural network. So it can actually learn and classify things easier. And then you have the machine learning or the machine learning architecture itself that can contain several parameters. So we have seen in the previous videos how to collect some data. We're not going to go through that again. Once you've collected enough data, you usually go to the Create Impulse tab. This is the place where you design your machine learning model. And from there, you can start defining some of the parameters, whether it's the input size, so the window size, it's actually the length of the sample that you are going to classify when it comes to time series data. It can also be the image size for images projects. Then you can choose a pre-processing block if you want. This usually helps the neural network to learn easily. When it comes to the digital signal processing part, so pre-processing like raw data to extract meaningful features, you can choose from several blocks that are already available, whether it's audio MFCC, audio MFE, a spectrogram. You can just use raw data, or you can also, for images project, select, for example, the depth of the colors, whether it's grayscale or RGB. Then about the neural network, again, you have several options. You can use transfer learning techniques. You can also use default classifier. In those, you have like different architectures that you can choose. Let me just go back quickly on the pre-processing. Here it's the MFE block. So you have several options, and those options, so those parameters can have a huge impact on the device's constraints. Here, for example, if you change the frame stride, if you move from 0.01 to 0.02, you can see like you can go from the processing time, so the time needed to pre-process the data. It goes from 332 milliseconds with a max of 25 kilobytes to something way smaller, so 171 milliseconds and a max peak RAM of 17 kilobytes. So this is more powerful, but maybe the features are less understandable by the neural network. Then when it comes to the neural network architecture, here on this screen, you can see a mobile nets transfer learning technique, but you still have a couple of parameters that you can adjust, whether it's the number of training cycles, so the number of epochs, and the learning rates. On other kind of projects, you might want to write your own neural network architecture. You can use like standard 1D convolutional, and those have different layers in the architecture, so in the deep learning network. Or again, you can choose another, like that's another template which has a 2D convolutional neural networks. Those architectures can be really different, and it really takes some time to feel what would be the best neural network architecture. So the main problem is that the model architecture can contain many hyperparameters. Just for recap, we've seen the windowing, so the window size or the input size that you want to use, the DSP, so the number of fast Fourier transform filters or the fast Fourier transform length. And this is only on one specific digital signal processing method. And then on the keras part, so the neural network part, you can choose in between different architectures, and you can have different layers as well. So picking the right value requires a lot of experience and trial error. And for some parameters, I don't even know how they work or what's the impact it will have on my model and on my model performances. So even if it will fit on my device. So let's go back to what we know. What we know is which target. So usually, which target do we want to run the neural network or the model on? So usually we know the desired latency. So how long do I need my model or to take, or my function, like my whole block function to take before giving me a result? If I know the target device, I know usually the RAM and the ROM, the flash footprint, or at least what is available. And then we've seen that there are so many different options. So here we can have 4 options for the window size or the window increase. We can have 4 options for the fast Fourier transform filters and fast Fourier transform length. My neural network architecture can be based on convolutional 1D or convolutional 2D. It can have several layers and several convolutional filters. So those make like thousands of possible variants of my model. So this is why we released EON Tuner more than a year ago, and the goal was to design the optimal machine learning solution within the constraints of your device. So what we want to do is to make the most of limited and heterogeneous compute, find the perfect balance between feature extraction and model architecture. We want to provide recommendation based on real performance metrics, and it has been designed and built for constrained devices, so the really tiny devices that has almost no RAM and ROM availability. Also, it works on high-end and complex projects such as complex object detections. And we also provide suggestions on optimal hardware target for your use case. So this is the view that you obtain when you want to create a EON Tuner job. You can find the EON Tuner tab on the left menu. When you click on Start, configure the targets, you will only need to choose 3 options. First is the dataset category, so you can choose between 4 options. I think I will see that in the next slide. Then you can select the target device from all the list of the official device or official board that we support. And then you can define your max inference time. So in the dataset category, here it recognized that in my data acquisition tab, I had audio audio files. And so it will give me 3 options here. So whether it's a keyword spotting model, it's audible events, or it's continuous audio, such as like industrial machinery noise that you want to detect. Then you can click on Start the EON Tuner. This will take up to 30 to maybe an hour So it can launch several different jobs in parallel and then give you the best model based on your constraints. So you have on the one side the latency, you have the RAM, you have the ROM, you have the confusion metrics, and you have the inputs here. So the window size, the window increase, which parameter for the digital signal processing is chosen, and then you have the learning block parameters, and you can compare those in like in one view. You have up to I can't remember how many different options that you have. And if I zoom on the filters, so you can filter by the validation set or the test set. You can sort, for example, the accuracy might be not the thing that you want to focus on, but rather the latency, or you want to keep some RAM or flash size on your device because you need your project you need to include that in a project that already consume or already have some files and some compute needs. You can filter on the F1 score or the precision or the recall. So those are the options that you can use. And then you can just click on select and automatically it will feed in the impulse design all those parameters according to what you selected. So this is great. You've seen it's super simple. Within 3 clicks, you can train on your network. You just need to focus on your data. However, it's sometimes too easy. So for different use cases, we noticed that the EON Tuner was not enough and we need to constrain the search space and also support some custom blocks that our customers and user provide. If they have techniques that they've been working on internally and they want to upload that to the studio and use those. And those are things that we do not officially support, but we want our users to be able to use them within the EON Tuner. So back in September 2022, we released something new, which is called the EON Tuner Search Space. And the EON Tuner Search Space, well, let me give you an example, for example, why you would need to constrain the search space. So for example, you already purchased some cameras and those only work with the grayscale depth, color depth. So for example, in that case, it's completely useless to search for RGB models to make sure they are okay. You want to only concentrate on one specific features of your digital signal processing block. Another option could be like you have engineers in your company that have spent hours or weeks working on a dedicated signal processing technique, and it has been proven to work. So you want to use this one, but you still want to enlarge the scope of the neural network architecture. You're not sure about it, and you want to use that. And another example could be like you have internally like some great data scientists that just have the feeling that a particular neural network architecture will work best because they've been working on a paper around this kind of architecture, and you don't know about the digital signal processing. Maybe having a different technique would help. So you would just want to search for that. Here is one example that actually happened to me. I wanted to check how I could reduce the size of because by default, when we were doing image classification, we needed to use transfer learning using Edge Impulse Studio. And these transfer learning models, even if I chose the smallest one, so the MobileNet V1 using a 0.1 alpha. So that's the bare minimum that I could use. Even for that, the inference time was still 338 milliseconds, and the RAM usage, or the peak RAM usage, was 55.3 kilobytes of RAM, and the flash size was 106.6 kilobytes. So I wanted to reduce that, and I wanted to test a technique. So if I was using some custom image processing before passing that to the neural network, I wanted to see if I could reduce the on-device performances while keeping a good accuracy. This was kind of hard to do at the time because the EON Tuner was not there. Well, I managed to write a blog post around it. Feel free to have a look. But this is to say, like, if I had the EON Tuner search space at the time, things would have been way easier. So how it works, the EON Tuner, so it uses templates. Those can be a bit hard to understand at the beginning, but basically a blank template looks like the following. So you have input blocks, you have DSP blocks, and you have learning blocks. Those are the three things that are contained in your machine learning pipelines. So to understand the core concepts, what I recommend usually is to load templates. We have ready to use templates and modify them as you want. We provide templates for different categories as well. If you already trained an impulse, you can just load that and then open up different fields. So the search parameters in the block, elements inside an array are considered as parameters. This means you can stack several combinations of input blocks, DSP blocks, and learn blocks. So in your template, each block can contain several elements, such as like the main array can be like a combination of input, DSP, and learn block, and then you can stock those. And you can also inside an input block, for example, put different image size that you want to test. So 96 by 96, 128 by 128. So it will test both combinations. Once you've played with it a couple of times, it's super powerful and it's great. So I really recommend to have a look at it. Unfortunately, as EON Tuner jobs are pretty long to train, I won't do a live demo on this, but this is all you need to know. Feel free to create an account on Edgeable Studio if you haven't done so. You can also use the evaluate getting started wizard to build your model in 5 minutes. And you can find the EON Tuner documentation on docs.edgeable.com/docs/Edgeable Studio/edge impulse /EON Tuner. And I want to thank a lot IoT Central for hosting this workshop. You can find more workshops and Edge Impulse MicroSession on iotcentral.io. This video will be also accessible on demand. If you have any questions, feel free to reach out directly on the forum, forum.edgeimpulse.com. And we'd love to see what you build. So make sure to share, whether it's on social media or even on the forum, what you've built with the EON Tuner AutoML tool. Thanks a lot. That was Louis Moreau from Edgeables. Have a great day.